I have a video. It's it's about a year ago, and I did this one by using three methods. Now I found that today is some better methods, very good method. So I would like to add this method as a fourth method to my previous video. So I hope you can you know stay tuned to look through the all four methods. Okay. Method one. Now I write e to x dx as a d e to the x. Okay, then I can use by parts. This is my u, this is my v. U dv is equal to uv, u times v, minus integral v is this, du. This is du. The derivative of x sine x with respect to x is this. Okay? Then I can break up the parentheses, become this minus this integral minus this integral, right? Each on this. I denote this integral as a blue integral, and I do the integral, the blue one, associate ex dx as a d e to the x, and by parts again, u dv is a uv, u times v, minus the v du. This is v, this is a du. The derivative of cosine x times x is this. Now, then this is this integral plus this integral. Okay. Now this integral is I. This is my original integral I, right? Therefore, I plug this back to here. My I will be equal to this minus this integral minus the blue minus this one plus this one and the minus I. This is I. Then I move this I here, I get two I's. So two I will be this, and this, and plus this integral. I denote as a red integral. Then I do the red integral. The red integral is this, and I associate ex dx as a d e to the x. Then by parts again, uv minus v du, this time this derivative, which is a negative sign, so it becomes plus again. So this is the integral of ex cosine x dx. Then I plug this back to here. Then my 2i will be this, then followed by the red one, which is two terms. Then this integral cancel with that integral. Left over divided by 2 is my I. Lots of tedious writing, and so this is the reason I wrote before, and just to avoid tedious writing and possible careless mistake. Well, I think quite many steps. Well, but anyhow, it's a nice result. Now this is my method of 1. Method of 2. Method of 2 is that ex sine x dx, this integral, you must be familiar with it when you learn the method by parts. This is the integral you must have seen it, or you must have done it. This result, the integral is half e to the x sine x minus cosine x. Therefore, the derivative of this with respect to x is ex sine x dx. Okay. Or if you haven't seen it, you just differentiate this. You can get ex sine x dx. Okay, so in other words, I rewrite this integral into this form. So the method by parts can be followed. This is u, this is dv. So uv is v times u is this. Minus the v du. V times du. Du is dx. This is v, right? Times by over 2. Then this integral become 2, right? Minus half this integral plus half ex cosine x dx. So this integral we have seen in a method of 1. This integral is this. So we simply replace the result. You get this is this minus this is this. This one becomes this. This integral is this plus that. Okay, let me see it again. Okay. That integral is this. All right, then and this one cancel with that one. This is cancel out. So I get result this one plus this one plus c. That is the result of this integral by method 2. Now method 3. Method 3. Method 3 is a very nice method, but rather tricky. First, I consider this, differentiate this one with respect to x is this. Obviously that we consider this is a one factor, x times sine x is the other. Then we use a by product rule. So this derivative is e to the x times x sine x plus e to the x times x sine x derivative. That is this. This is the derivative of x sine x with respect to x. Then similarly we do this. This derivative, we use the product rule, we get this. All right. This equation 1, this equation 2. Now, equation 1, if you integrate both sides, this side integral is this. This side integral is this integral plus this integral plus this integral. You have 3 integrals, right? Similarly, equation 2, if you integrate both sides, this side is this side is you have 3 integrals. Okay, so this integral minus this integral. Now I have to slow down. This integral minus this integral, 1 minus 2, huh? The left-hand side, the left-hand side is this minus this. This minus that. You have a common factor, and you have this. So this is the left-hand side after the subtraction. Now then the right-hand side, this minus this, this minus this, this minus that, right? So this is I, that's the origin I. This is also I. So this minus this become 2 I's. And this is left over. This is this. And this minus that cancelled out. You see? This minus that in the right hand side, right? This is cancelled out. This is I. This I is 2 I's. So 2 I's plus this one minus that one. Well, should I repeat that one again? We subtract 1 by 2. Okay, then this one minus that one. The left hand side is this minus this. After simplify, you get this one. The right hand side, this one is I. This one is also I. So after the subtraction becomes 2I. And this is this. And this one minus that one cancelled out. Left over this negative, okay? Now, I have this red integral again. This red integral is this. So I replace these two. I get this one minus that one. So 2I, this is this. This one is replaced by these two. These two. You get this negative, right, after subtraction. Then this might cancel with the other one. So you're left over 2I minus this. This is the right hand side. Left hand side is this. So 2I, you get that one. Same answer. Fourth method. Method 4. This is a very good method. Really, really very good. I'll let this integral be I. So I is my target integral. And I introduce another integral j, which is a integral x e to the x times cosine x dx. Okay, these are two integrals. Then I plus j, this plus this one, right? They have a common factor, which is x e to the x multiplied by sine x plus cosine x dx. So this integral is equal to x ex sine x plus ex cosine x dx. And this is the derivative of e to the x times sine x, the product rule. So this one is equal to x d e to the x sine x. Well, this derivative is e to the x times sine x plus this one time this derivative, which is cosine. So this is equal to that. So by doing this way, I can use by parts. So this one is equal to uh, this is u, this is v, right? uv minus v du, the integral v. V is this. Du is a dx. Okay, so this is I plus j. Now I'll do the same thing for I minus j. I minus j is equal to this minus this, right? So this one is equal to x e to the x sine x minus cosine x dx. And this is x ex sine x minus e to the x cosine x dx. So this is the derivative of the product, which is equal to x d e to the x cosine x. Because this derivative is this times cosine negative. Sorry, there's a negative here. And then this derivative times this derivative, which is positive cosine. Yeah. Let me check it again. This derivative times this one is a negative sign plus this derivative times this one. Yeah, it's correct. Now then by parts, by parts, right? This is negative x ex cosine x plus integral v du, right? E to the x cosine x dx. Yeah, this is my I minus j. This is I plus j. We are looking for I, right? So 2I is equal to I plus j plus I minus j. So this one plus this one. Well, let me write this one. This one plus this one, right? The common factor, x e to the x sine x minus cosine x. This one plus this one, right? This one is equal to common factor and then cosine minus sine. Minus sine is dx. Okay, so this one is equal to x e to the x sine x minus cosine x. This one is the product, the product rule of e to the x cosine x. Right? Let's check this integral. This derivative is e to the x times cosine, and times this one times this derivative was a negative sign. Yes, it's correct. So it's end up with x e to the x sine x minus cosine x plus e to the x cosine x. Yes, plus c, right? So therefore, I just simply means half of it. So this is 1/2 x e to the x sine x minus cosine x plus 1/2 e to the x cosine x plus this is half c, right? This is c. Yeah, this is a very nice method, to make a complicated integral rather easier, very easy. Okay, I hope you like it. Thank you.